how is everybody tonight? My name's Ahren Gross again, and it's good to see you here. I thought, do you have show and tell at your school? Yeah. Yeah? Well, I went out in our yard today, and I picked up some parts so I could do show and tell. So, yeah. So, yeah, I have number one here. I've got my little barricade that one of my employees made for me. It's kind of a joke. It says groundwater on it, but I can't really, it'd be a long story to explain that, but he made this little tiny barricade for me. So if you ever see barricades out on the street, we usually use cones, like the tall cones, but we do use barricades sometimes. And an interesting thing about a barricade, and Adam made this, and just so when you see a barricade, you see how the lines go off to the side there? That's the direction that you're supposed to travel. So as you're driving through town, if you see a barricade that is like the other way, like this, but then the traffic's going this way, they got their barricade backwards, so you'll know then. But for safety reasons, it kind of tries to help point you to where you're going. So I brought in some pieces of the picture there so you could see in real life what Brian found on the internet of a service line. And our city, does anybody remember how many miles of pipe we have in Muscatine? Ooh, go ahead. It's on your sheet. It was from Muscatine to Adventureland, if you remember.
I remember.
He's looking really hard. 156 miles, that's right. So if you live in the city of Muscatine and you are on city water, more than likely there's a pipe that runs down your street. So, and the pipes that are running down your street are a lot like this pipe here. And this is a 6-inch PVC. And we just started installing PVC 2 years ago in Muscatine. Before that, all the pipe that we put in was metal. And if this is ductile iron, we talked a little bit about that the other night, about ductile iron pipe. And this is the same size, it's 6-inch. But I would not be able to, if this pipe was this long as a PVC, I wouldn't be able to pick it up because it's really heavy. And it's a little dirty too, so I'm not going to pass it around. There's some sharp edges. But one thing that's interesting about this type of pipe, and you can identify it as a newer metal pipe because it has these dimples on the outside. And the other thing is, a lot of the older pipe is cast iron. That was kind of the precursor to this type of pipe. And it's a lot thicker metal. Another interesting thing about ductile iron pipe is that on the inside of it, can you see what's that inside layer there? Can you see that layer all right from the back row? That is cement. That's a cement lining. And then it actually has an asphaltic coating on the inside to keep it, so that protects the metal pipe from corroding. When the cement lining, if say this pipe is dropped out in the yard after we unload it, and it might chip a little bit, and if you don't notice it, 30 years later that pipe may corrode through that lining. So the lining is really important that that's there. So the nice thing about the PVC is there is no lining on it. So it's all the same material. And PVC, or another type of plastic that we use, is called HDPE, and that's high density polyethylene, and this is PVC stands for polyvinyl chloride pipe. So it's a chemical process, and they actually make this type of pipe up in West Liberty at JM Eagle. So it's pretty close to where we're at. So these pipes are on the streets, and the picture we have up here shows our water main, and so that's the larger pipe there. On the label here, we've got the water main. We've got a corporation stop, which is like a valve. I'm going to show you one of those. A little gooseneck, they call that. That's to keep the service line from breaking, because it's an attachment point into the bigger main. And then the service line is the smaller diameter pipe that actually goes into your house. halfway in between, and usually it's right on the edge of the street, is the curb stop valve, and that's another valve. I don't have one of those with me, but the corp stop looks a lot like it. And then inside your house, probably either in the basement or in a room, in a closet, you'll see the water meter. So when you go home tonight, you can look for your water meter and see if you can find it. So we've got our large pipe, the main, we call that the water main. And then off of that is the service line. And I brought a piece of service line material that I got out of the yard today. It's got a little, we call this a little patina. Usually it's really shiny, but it's been out in the weather, and when it's in the ground, it starts to turn a little bit different color. But you can kind of see this is a copper pipe, and you can see the kind of the shininess of the copper, like your copper penny. Now, the guys say this is a really easy pipe to install because it's flexible, but I'm just going to show you. It's not that easy to install. You kind of have to take it, and you have to bend it. It takes a lot of muscle, and I might trip and fall over. So I'm not very good at this. I'm not in as good a shape as I used to be, but it's flexible. So they can bend it like that. And they usually lay it out flat, like in the picture that we had up there, where it's flat going into the house. So go ahead.
Isn't there a tool that you can use that's technically called a pipe bender?
There is a tool that you can use that's called a pipe bender. You're right, yep. But usually when it comes coiled up on a roll and they're going to install it, they'll do just like what I did. They'll kind of stand on it and roll it out flat and then put it in the trench there. So I also have with me an older type of pipe material. Have you heard about lead service lines, lead in the news at all? Has anybody heard about that? Okay, there's still some lead service lines in Muscatine. The good thing is our water isn't very corrosive, so it doesn't leach the lead out. But I brought a piece of lead pipe in, and you can see how thick that is. Just a little chunk of it. So one of my employees had this in the back of this truck. I just wanted to bring it in. So that's another thing you can check tonight when you go home. Look for your water meter. You can see if it looks like copper. It may look like this, like lead. I live in an old house, and I have a galvanized service. So my service is like this, but it's straight, very straight, because galvanized pipe is almost in that shape. It's very vertical, straight. So lead is malleable or bendable, just like copper is. I wanted to show you the corp stop. So off the main at the street, oh, Brian's got another picture of that up here. Here's the water main. This one has a saddle on it, and then the corp stop is going into that saddle. Most of our corps, and this is a corp, we call it a corporation stop, and it's actually a valve. It's got, see the little edge on here? You would take a crescent wrench and turn that to turn it on or turn it off, and this stays buried. The only way you'll ever operate it is if you dig up the street or dig up the yard and expose it, and then you could turn it off. If you had a leak on your service line, that'd probably be about the only time that you would use that. The cool thing about water, the water industry, is it's basically been the same for the last 100 years, except lots of improvements. So we started off with service lines made out of lead, and then we went to service lines made out of copper. We've always had kind of a corporation stop that looks like this, but I've got an older one. It's a new corp stop, but this is out of our drawer at Power and Water. We keep a lot of the older styles just in case somebody has one that breaks, and then we have one that they could get from us and they could use it. And see, it's a little bit, what's the difference between, let me unscrew it here. What's a little bit different that you can tell from this style to this style? Oh, go ahead.
It's smaller.
It is definitely smaller. It is smaller. Another little difference is the type of valve that it is. It's got a little bit bigger ear on there. So this one's a little more protected. It's a newer style. One of the things I find interesting is this is a flared outlet. So they would actually take the pipe and bend it inside of this nut, and this would go over the pipe and slide onto here, and then when they tighten this, it actually tightens the pipe to the elbow that's here. On this style, this is different. This is called a compression fitting, and this is a newer technology, and we're starting to use these almost exclusively because it connects a lot tighter and it's a lot easier to connect. You can do it a lot faster. But inside there, there's this little ring, and there's a little tiny ridge to that has some little ridges on that ring. And as you tighten that nut down, that ring grabs a hold of the pipe. So on this one, it's actually beveled out to hold, and it's something that the plumber would do himself. On this one, basically they just tighten it and it's connected. So different, basically the same thing, but a little improvement. Let's see. One of you asked the other night about water main breaks, how we fix water main breaks. I can't remember who asked that question. Anybody volunteer that they, oh, you asked that question, okay. This, I brought a clamp. This is a clamp that we've used before. It's a stainless steel repair band, and for probably 90% of our water main breaks, this is the type of repair that we make. You either cut the pipe in two ends and put a new piece of pipe in the middle, or if you've got a hole or a crack around the pipe, you'll put this is what the operators will put on. And they're not that easy to put on. It's really kind of an art form to see the guys do this. It takes a lot of strength, and usually the water is shooting out of the hole or the crack in the pipe at the same time, and they'll pull this apart. See, I kind of had to struggle with that, but if you're in you can just imagine you're in a trench in a hole, and your pipe is leaking. You got to spread that around, and then pull it over and clamp it. And on the inside, it's got a piece of rubber that's fairly thick, and then the stainless steel. So it basically puts a pipe around the pipe that's broken. So it's kind of like one of our operators, Neil, likens it to he calls it a water main Band-Aid. So it's kind of like a Band-Aid that you put on. But
Those come in various sizes then?
all different sizes. Yeah, this is a 6-inch, probably our most common one. When they're new right out of the box, they're all shiny. I think we used this one before, and we just put it on our shelf in case we had a pipe that wasn't pressurized that we needed. I don't know, we can't hang on to it because it's not bad enough to throw away, but it's not something we'd put on a main break normally. You know, we'd use a new piece. So, and then to tighten the bolts down, once you get it clamped, see, I'm gonna struggle a little bit clamping it. Put that clamp down. I'm on a workbench, so then you tighten it down, and then we have a wrench that'll fit over the nut, and then they'll tighten that down. I was going to bring one of our impact wrenches. A lot of times our employees use they call it an impact wrench. It looks like a drill, but they were using them today, so I grabbed the old method, the old method, the wrench. So usually they'll use the impact, and then they'll put the wrench on and tighten it a little bit more. So that was that. And then one of my favorite things to share with you today is a valve. So this is a 2-inch resilient wedge gate valve, and it's brand new. I got it out of the storeroom, and I'm going to take it back when I'm done because we only have one of these of this size. This 2-inch isn't very common in Muscatine, but anywhere from 2-inch to 30-inch valves is what we have in Muscatine, and they all basically look like this, except the 30-inch valve probably comes up to my waist, and then the bonnet, this is what you call the bonnet. The bonnet's probably above my head. So this valve is about $250 to buy this valve. To buy a new 30-inch resilient wedge gate valve like this is about $14,000. So it's a big difference between the two. So actually in this year, We're putting in a new well field, new transmission main, and we bought some 30-inch valves. I'm not sure how many valves we bought. It was probably four 30-inch valves, so that we put in our system this year. So just today, Brian had a question for me. Asked how many. Well, we have. Let's see. We have. I can't remember the exact number. I think it's 4,000, about a little bit more than 4,000 valves just like this in our system. Most of them are the 6-inch size, so the round part is the 6-inch size. But these valves are about every block, so on every 400 feet we'll have one of these valves. So if we have a problem, we have a main break, we're going to be shutting at least 2 of these. And so if you're ever out of water, that's probably what has happened, is we've closed a valve. So they're really important to work, because if our valves don't work, then we have to go to the next block. And usually if you have a main break in the middle of a block and you shut 2 valves and say one of those doesn't work, then you've got to go to the next block where you may have to shut 2 or 3 valves, and then it just expands our outage. So we've been really working hard the last several years to replace valves that don't work around Muscatine. That's kind of been one of our big emphasis to do, because as far as reliability goes, the valves have to work. So one thing, I just got this question the other day from someone at Muscatine Power and Water. We were talking about turning valves. Sometimes we go out and exercise these valves, and to turn them this is what I'm talking about. I'm turning the gate valve. And there's that gate in there is what closed. Actually, I'm opening it right now. I'll turn it the other way. I don't know if you can see that. I want to bring that around. So we'll turn valves, and when we do that, some of the sediment from the island aquifer, from our source water that we pump, some of that accumulates inside of the pipe, and that's why we flush twice a year. But that will break free, and sometimes people will get some discolored water at their house. You ever had that?
Yep, and I've also, a chunk was in one of our water things.
Oh.
So we had to, my mom had to explain how long it was. And she's going to put me into that.
Yeah, so it's really important that we flush twice a year. So that's actually coming up here, the middle of April we'll start that. We'll start flushing again. So if you see us out flushing fire hydrants, that's what we're doing. A couple of the other items that I brought, I guess I'm just a water nerd because I brought this, but this is one of my favorite items that we have in our warehouse. It's called a mega lug. This is a restrained joint. On these valves, if I had a 6-inch, this slides in there to fasten it to the pipe. So this fits over the pipe, kind of like so, okay? And then to do that, you have to, oh, did somebody have a question? Go ahead. When was? Yeah. Well, we flush twice a year, so more than likely we did. So I've got another piece. This is a regular gland. So just to kind of demonstrate, all this work is taking place in a trench, but the gland fits over, and if I'm using my restraint joint, this will fit over the end. That'll fit over the end like so, and it's kind of heavy. Brian's arms are going to get tired holding that there, so I better be fast. Then our gland, it's a rubber gland. That'll fit over the pipe. Again, it's not easy to do. You got to bend it. You got to kind of pull on it. But you need a tight seal. And I'm probably not going to get it all the way on there, but this would slide up just a little bit further. The pipe would go inside the hole on the valve or the hydrant. You'd slide that gland up, and then on all those bolts around the valve, the bolt would come up through and then tighten on the back side of the valve to fasten it to it. So there's a bolt all the way around, and then after all those are tight, then on the outside there's these little blue nuts, and those are the locking part of the megalug, and those will they'll actually tighten down and they'll fasten to the pipe so it holds it in place. So that's kind of a newer technology, probably in the last, I don't know, maybe 20 years or so. Probably the last 20 years they've come up with that. And we use that a lot. Probably everything that we put together is a restrained joint like this. And it makes a big difference because water's heavy. 1 gallon of water weighs 8.34 pounds. And in a 1 foot section of 6-inch pipe, I can't remember how many gallons it is. We'll have to look that up, but there's some weight there. And if you get to the area of 16-inch or the 30-inch like I was talking about earlier, you have a lot of weight moving through the pipe. So that's why we restrain it, so things don't pop off the ends. And I got greased up here. I'm just gonna rinse off real quick. So that's my show and tell for piping. You have a question in the back. Go ahead. To put in a 30-inch pipe, it takes a lot longer because on that 6-inch we've got 6 bolts to bolt up. On the 30-inch, I think it's even more than 30 because as you go around, they're a lot closer together. So, what's that? My pinky?
It looks pink. It looks pink.
What looks pink?
The water looks pink.
Did it really?
Yeah.
I was using some hot water though. I just have a couple other things to show you. One thing that we use to locate pipe is we have these metal locators. And I think we're probably the only ones in Muscatine that have locators like this is at Power and Water. And as you're searching for a valve box, I have steel toe shoes on. And it kind of makes a so you can a lot of these valve boxes, I didn't bring a valve. The one thing I didn't bring was a valve box lid, but the valve box lids kind of look like that. So that's how we find our valves if they're covered up with dirt or grass. And ductile doesn't really sound off as loud as cast iron. I don't think I have cast iron with me, but it's a lot louder. So I wanted to show that to you. If you ever see one of these laying in the boulevard along the street, please call Power and Water. So we haven't lost very many, but every once in a while somebody will get busy and they'll lay it down and forget it's there. So I always lock my work truck up because I want to hang on to my metal locator. So what else? Oh, I wanted to show you this. If we get a sample off of a fire hydrant, we have these little kits that we can put on the nozzle of the hydrant with our sampler here and then run water out of it. And this is a smooth nose sample tap. And so you don't see a lot of these around because you can't hook a garden hose up to it. But bacteria like to grow on those threads of the garden of your house bibs. And on these they're smooth so that we can spray an alcohol solution on them, disinfect them, then flush, and then we can take our bacteria sample, and that keeps us from getting a bacteria sample that isn't representing the water that's coming out of the tap, but the bacteria that was living on the thread. So these are an important little tool that we use quite a bit also. So don't think I have anything else to show you on that. Any questions on my show and tell today? How it all comes together? Go ahead.
The metal locator is kind of like a metal detector.
It is a metal detector. You're right. Yep, it is. Yep, just like that. It's just a little bit different shape than probably what you've seen before. So, anyone else have any questions? Go ahead.
How much pipes do you have to put in to get to Adventureland?
How many pipes to put in to get to Adventureland? Or It was 156 miles of pipe. So that's what we have in Muscatine. So I was kind of thinking about that last night. It's hard to imagine that all the streets in Muscatine and all the areas and connecting different neighborhoods, it adds up to 156 miles. But if you consider from our source at the wells, which are pretty remote, all the way to the city of Muscatine, it's a long ways. So. Ooh, I don't have an answer for that. We'd have to look. We'd have to Google that. So, I saw somebody's hand over here.
I noticed that the blue pipe that you say runs underneath most of the street versus the copper pipe that goes into the house. There's a big difference in size.
There is a big difference in size. Well, there's a couple of reasons. You've got all the houses that are connected to it with the smaller diameter pipe. And you don't want somebody to be running their faucet down the street and take water from your house. But the other big thing, and I'm glad you brought that up, is fire protection. So the reason why the main is so big is because it feeds a fire hydrant, which the fire department would connect to fight a fire if there was a fire at your house. So we're trying to meet the fire flow demand. So the minimum requirement, the recommended minimum requirement for fire flow is to have a 6-inch pipe connected at both ends to a source. Or if it's what we call a dead end or a radial feed or a street that stops, the minimum is 8-inch. And what we're trying to be able to provide is 1,000 gallons per minute from that fire hydrant. So it's pretty amazing. I don't know if you've probably seen us flushing, but usually throughout the year, if someone's going to build a new building or there's another development going in, some sprinkler companies will call us and they'll ask for a fire flow test. And I'll send a couple of people out to flush a hydrant. And what they do is they actually have a 2.5-inch opening, which is about the same diameter as this. It's a 2.5-inch opening on the hydrant. And they'll open the hydrant all the way and the water will go shooting out probably to Brian. And they'll measure that flow, and it varies where you're at in Muscatine for the different pressures. Could be different sizes of main, but usually they're looking for at least 750 gallons per minute on those tests. So actually last year, the insurance company, the ISO, came and got with the fire department and questioned us and had us go do flow tests. And we have a rating of 3 out of 10, as 1 being the best in Muscatine, which is actually really good. So there's always improvements to make, but we were looking at fire flows, and I think all the hydrants that we flushed were over 900 gallons a minute. So that's a positive thing. I'd like to do some more water testing tonight because we talked about that. Do you want to do some more water testing? Did I hear yes? Okay, good. That's good. I wanted to review a couple things from the other night. I've got a few directions. I'd like to go through the directions once, but let me pick up just a little bit here. Get a little. Okay, can anybody remember how we disinfect our water? What we were testing for the other night? How about in the blue shirt back there? Chlorine. Okay. Do you remember? That's correct. Do you remember what part per million we feed through most of Muscatine? Okay. It was around 1.0, 1 part per million. How much? Do you remember how much a part per million was? If you had like an example of that. Go ahead.
So if I had 999 wet white golf balls, put them in a pool, and I took one yellow one, I threw it in there, that's 1 of a million.
I like your analogy. I like your analogy. So, yeah.
Based off of somebody else's.
Or it was 1 penny to $10,000, or one inch to 16 miles. And there, I had another example, but I lost it. So it's a really small amount. Yeah, so up on the board tonight I wrote out the directions to use the colorimeter to analyze the water for chlorine. So the first step is to fill that small sample cell with water, and that was your clear spot here, right? So you fill it. Hey, over there in the corner, what's my second step then? Okay. Press the power button. Okay, I got to get my meter out. Power button was the middle one, right? Okay, turn it back on. It's going to talk about zeroing next. Okay, so the next step, maybe in the middle in the back row. What's my next step after that? Oops, she's checking the water. Do you remember what my next step? I kind of. Okay, remove the cap. So the cap was this middle part here, right? Take that off. Then our next step was to zero it. So I already dumped out my sample, so I'm going to get another one. So we got a zero. Remember, we got to wipe off the cell first before we place it in. Missed a step on my procedure, but you'll have to remember that one. Then the next step is to zero. So you press your zero button, which is the blue. Okay. It zeroed it out right to there. I went back to zero. Then you use your DPD, which is in the little dispenser. You got to take your cap back off. This was a step we missed the other night. I don't think we went through 20 seconds of shaking. Ooh, this doesn't have very much in it. Didn't really turn pink, did it? It doesn't. I can remedy that though.
We zero it out with color.
Ooh. Yeah, it will be.
We won't get the right reading, will we? Did we maybe forget that once in a while? Do you have to zero it out more than once? Once you zeroed it out to clear, you can test it as many times as you want. But if you forget to zero it out in the very beginning, then it's not.
Still kind of clear.
Yeah. I don't think that's good.
What's that?
There's nothing in your water?
Sometimes in buildings that have sat for a while, there won't be much chlorine left because it tends to dissipate. Remember, what kind of state was chlorine? What was the 3 states of matter? Here, I'm going to ask over here in the back row, the gray shirt. You remember what kind of state chlorine was? You can help her out. You can phone a friend. Liquid or gas? Yeah, in the cylinders it was liquid, and then as it's taken out, it's a gas. Yep. So it naturally wants to go back to that gas phase. So what happens if you turn your faucet on and you smell chlorine? Go ahead.
The gas will turn to...
It's turning back into gas. You're smelling it, so it's really there's no chlorine, there's no aqueous chlorine in the water anymore. It's not part of the water. It's reverted back to that gas. Yeah. Now I brought some chlorine with me in the form of bleach tonight, so if we don't get any here, I can add a little bit to a jar. So, yep, still white. I'm going to test it anyways because we zeroed it. Let's see if there's any color in it at all, if it can pick any up. So after I take my sample and put the DPD in, oh, I got to shake it for 20 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi. I already went 5 Mississippi, so I'm going to go to 10, 11, 12, 13. There might be a little pink in there. Do you see it? So it's really important to wait. I might be getting impatient here.
I mean, I get it. You've been waiting for
Ooh, you know what? That's another lesson in water. It always takes time for that water to move. It doesn't move through the pipe very fast. In general, around Muscatine, it's moving about 2 feet per second, 1 to 2 feet per second. In areas where it's really moving fast, it's about 7 feet per second. So if you consider, like, some of our well fields might be half a mile long, you have to be patient for your new water to get up to the treatment plant. So if you make a change, you got to wait to see what that is. So I put my sample back in. I've got 0.07 chlorine. So I wipe the towel and then I press the read button, which is the check. It's the green button. And I got 0.007. So everybody's got their water running. Make sure it's the cold, and then let's go ahead and run a sample, and then I'll make up some other samples for you to test here with your glass jars. So you can use your sinks and then fill your sample, and then everybody should get a chance to do that part tonight. Oh, is that right out of the faucet?